Okay, today we are going to discuss about Mach number. Then we are going to define sonic flow, subsonic flow and supersonic flow. Then propagation of pressure waves or disturbances in a compressible fluid. Then we are going to define Mach cone, zone of action, zone of silence and its related problems. Now let us first define what is Mach number. Mach number is represented by capital letter M. So it is defined as square root of ratio of inertia force of flowing fluid to the elastic force. Inertia force is due to mass of the flowing fluid. Therefore, Mach number equal to M, that is the representation for Mach number, that is equal to square root of inertia force to elastic force. Now, inertia force is given by rho A V square. This you have to remember. And elastic force is given by K into A, where K is the stiffness. K is the bulk modulus. So, Mach number expression becomes M equal to square root of rho A V square divided by Ka. So, otherwise you can rearrange A terms, you can cancel each other. So, that is equal to square root of V square divided by K by rho, taking rho to the denominator. So, that time it becomes 1 by rho, so K by rho. So, square root of V square divided by K by rho, that is equal to V divided by square root of K by rho. Hope you remember the definition of or the expression for velocity of sound that is given by C equal to square root of dP by d rho, that is equal to K by rho, that is in terms of bulk modulus. So V divided by square root of K by rho, square root of K by rho is replaced by C, that is velocity of sound. So that is equal to V by C, since square root of K by rho equal to C, that is the velocity of sound. So Mach number is equal to ratio of velocity of flowing fluid to velocity of sound wave. So that is equal to V by C. Therefore, Mach number is equal to, you can define like this also, velocity of fluid or body moving in a fluid to velocity of sound in the fluid, that is equal to V by C. So that is the definition, very important. You have to remember here Mach number expression, that is equal to V by C. Now, for the compressible fluid flow, Mach number is an important non-dimensional parameter. This non-dimensional means Mach number has no unit. So, non-dimensional parameter, on the basis of Mach number, the flow is defined as, first one is subsonic flow, second one is sonic flow, third one is supersonic flow. So there are three types. Depending on the Mach number value, you can classify into three categories. There is a subsonic, sonic and supersonic flow. Next, let us define what is subsonic flow, sonic flow and supersonic flow. Subsonic flow. A flow is said to be subsonic flow if the Mach number is less than 1.0 or M is less than 1, which means that from Mach number definition M equal to V by C, in order to get Mach number less than 1.0, C value should be greater than V. That means the velocity of flow, that is capital V, is less than the velocity of sound wave, or V is less than C, that is for subsonic flow. Now sonic flow, that is Mach number equal to 1. In order to get Mach number equal to 1, definition of Mach number is V by C. So V and C should be equal. So I can define sonic flow as like this. A flow is said to be sonic flow if the Mach number M is equal to 1.0. This means that when the velocity of flow, that is V, is equal to velocity of sound wave, that is C, the flow is said to be sonic flow. So supersonic flow, already the two cases are over. One is value equal to 1.0, other one is less than 1.0. Now remaining term is greater than 1.0, that is applicable for supersonic flow. A flow is said to be supersonic flow if the Mach number is greater than 1.0, that is M is greater than 1. This is possible when the value of V is greater than value of C, because from definition of Mach number we have M equal to V by C. In order to get value of M greater than 1, we should have value of V that should be greater than value of C. So that is related to supersonic flow. So this is again very important concept. Three categories of flow: subsonic, sonic flow and supersonic flow. Now let us go for propagation of pressure waves or disturbances in a compressible fluid. So whenever any disturbance is produced in a compressible fluid, the disturbance is propagated in all directions with the velocity of sound. So I already explained about this thing in velocity of sound in compressible flow derivation, where the disturbances are created just because of the movement of the piston. Actually that is a three-dimensional case, but for simplification we consider only one-dimensional case. Here they're going to define about this thing. Whenever any disturbance is produced in a compressible fluid, the disturbance is propagated in all directions. That means it is in 3 dimension or 3 direction with the velocity of sound that is equal to c. The nature of propagation of the disturbance depends upon the Mach number. I already defined Mach number, that is equal to V by C, velocity of flowing fluid to velocity of sound wave. Let us consider a small projectile moving from left to right in a straight line in a stationary fluid. Instead of piston, we are going to consider here one projectile that is moving from left to right in a straight line. So due to the moment of the projectile, that is the projectile is going to move in a fluid, because of that there is a disturbance created. So due to the moment of the projectile, the disturbances will be created in the fluid. This disturbance will be moving in all direction with a velocity of c. There is a 3-dimensional case with velocity of c. There is a velocity of sound wave. Now let us consider, define the terms. Let v equal to velocity of the projectile. In previous derivation it was velocity of the piston or velocity of fluid, flowing fluid. Here v equal to velocity of the projectile and c equal to velocity of the pressure wave or disturbances for different Mach numbers. We have 3 cases of Mach number. One is Mach number equal to 1, other one is greater than 1 and other one is less than 1. So let us find the nature of propagation of disturbance for different Mach numbers. So first case, when Mach number is less than 1. So when the Mach number is less than 1.0, the flow is called subsonic flow. For Mach number, in order to get Mach number less than 1, that's from definition of m, that is equal to v by c. V value should be less than c value. That means v by c is less than 1 or v should be less than c. That is velocity of flow should be less than velocity of sound wave or disturbance. To find the nature of propagation for this case, let us assume 2 values for v and c. So in order to get Mach number less than 1, the value of v should be 1 unit and c should be 2 unit, so that v by c equal to 1 by 2, which is less than 1.0. It is going to satisfy the case, that is m is less than 1. Let the projectile is at A. There is some point you can see there. This projectile is at point A and is moving towards right. It is going to move towards right, that is towards B. Let in 4 seconds the projectile reaches to the position B. So it is going to move from A to B in 4 seconds. At A, the point 4 is also marked. You just mark at A. This is the I'll explain how to draw the profile here. At point A, you just mark again point 4. The position of the projectile after 1 second, 2 second, 3 second and 4 second along the lines are shown by the points 3, 2, 1 and B respectively. Initially the projectile is at point A, then it moves to a point, or it is at point 4, and then it moves to the point 3, then it moves to the point 2 and 1 respectively, and from 1 to B. So the projectile moves from A to B in 4 seconds and hence the distance traveled. I already told about this thing in derivation, that is velocity of piston or distance traveled by the piston is given by V into dt, where dt is small in time interval. So the projectile moves from A to B in 4 seconds. You know the time. And you know the velocity of projectile, that is 1 minute. So can you calculate the distance? So distance is given by, that is AB, that is equal to velocity into time. So velocity is v into time is 4 seconds. So v value we have taken it as 1. So 4 into 1, that is equal to 4 units. So 4 units. The disturbance created at A in 4 seconds will move a distance that is equal to 4c. Can you guess how I got this expression? So from distance traveled by the sound wave, that is given by that is L equal to c into dt. We took c as some value as 2 unit, and time interval is 4. 4 into 2, that is equal to 8 units in all directions. But you have to clearly note down here the difference between distance traveled by projectile and as well as distance traveled by sound wave or disturbance. So for projectile you have to take velocity unit v equal to 1 unit, and for disturbance c equal to 2 unit. So distance traveled by the disturbance is given by 4c, because velocity into time, velocity is here c, into time is 4. So 4 into 2, that is 8 units in all directions. Hence taking A as a center and radius equal to 8 units. So you know the first initially you draw the straight line AB, then mark the point A and 4. Now taking 4 as the center, you just draw one circle with the radius equal to 8 centimeter. That is the outward circle. Next, this circle gives the position of disturbance after 4 seconds. Okay, this is the circle for after 4 seconds. When the projectile is at point 3, now what is the time? When the projectile is at point 3, it reaches to be in 3 seconds. So you have to take time as 3. Now, when you are going to take time as 3, when the projectile is at point 3, it will reach B in 3 seconds. And distance again, the projectile V into dt, V is taken as 1, 1 into 3, that is equal to 3 into 1, equal to 3 units. But the disturbance created at point 3 in 3 seconds will move a distance having a radius that you have to calculate here, that is C into dt. C value is 2, dt is 3, 3 into 2 into 3, that is 6 units. Now, taking 3 as a center point, draw one circle with a radius equal to 6 centimeter. That shows the propagation of disturbance. Similarly, when the projectile goes to point 2, it requires 2 seconds to reach point B. So now, the distance traveled by the projectile is given by V into dt, that is 1 into 2. So that is 2 units. Then similarly, the distance traveled by the disturbance, that is given by C into dt. So it requires 2 seconds to reach B. So 2 into 2, that is 4 units. So taking 2 as a center point, draw one more circle with a radius equal to 4 centimeter or 4 units. So that shows the disturbance propagation. Similarly, take the point 1, consider point 1, where the distance traveled by the projectile, that is, it requires 1 second to reach point B. So distance traveled by the projectile is equal to V into dt, that is 1 into 1, that is 1 unit. Now distance traveled by the disturbance, that is given by C into dt. C value you have already taken as 2. 2 into 1, that is 2 units. So taking 1 as a center, draw one more circle with a radius equal to 2 units. So that is the case for m is less than 1. Hope you understood. First you have to draw one straight line AB and mark at point A, point 4. Then the point A reaches, the projectile is initially at A, that reaches to point B in 4 seconds. So time is initial case is 4. Now, so distance traveled by the projectile is 4 into, that is V into dt. V into dt means V value we already taken it as 1, 1 into 4, that is equal to 4 units. Now distance traveled by the projectile is given by C into dt. C value we already taken as 2, 2 into 4, that is 8 units. So taking A as the center, draw one circle with a radius equal to 8 centimeter. So now projectile moves to point 3. At point 3, the distance traveled by the projectile is given by V into dt. Now from point 3 to B, it requires 3 seconds to reach. So 3 seconds means V into dt. So 1 into 3, that becomes 3 units. Similarly, distance traveled by the disturbance, that is given by C into dt. C value is 2, dt is 3, 2 into 3. So taking 3 as the point, center point, draw one more circle with a radius equal to 6 unit. So that shows the propagation of disturbance. Similarly, 2 and 1, you can draw the circle. That's a case for m less than 1. Now second case, when m equal to 1. When m equal to 1, the flow is said to be sonic flow. In this case, the disturbance always travels with the projectile. So V equal to C means V is the velocity of the projectile, C is the velocity of sound wave or disturbance. So in order to get value of m equal to 1, the values of V and C should be equal. That means that they are going to travel in like same time. So as shown in the figure B, let V equal to 1 unit and C equal to 1 unit. Just take values of V and C as 1 units, so that m equal to V by C, that is equal to 1.0. Now I'll explain the case here. Similarly, you have to similar to previous case, m less than 1, just draw AB line. Now at A again mark point 4. Now for the projectile to reach B, it requires 4 seconds. So distance traveled by the projectile is given by V into dt. So V value is 1, 1 into 4. So this is the 4 units. Now distance traveled by the disturbance, that is given by C into dt. C into dt, C value is 1 and dt value is 4, 1 into 4. So taking A as the center point, draw one circle with a radius equal to 4 units. Now the projectile moves to point 3. So this time taken for the projectile to reach point B is 3 seconds. So the distance traveled by the projectile is given by v into dt. So 1 into 3, that is 3 units. So distance traveled by the disturbance is given by c into dt, that is 1 into 3. So 3 units. Taking 3 as a center point, draw one circle with a radius equal to 3 centimeter. Now the projectile moves to position 2. So time for the projectile to reach point B is 2 seconds. So distance traveled by the projectile is given by v into dt. V is 1 unit and dt is 2 units. So distance traveled by the disturbance or sound wave is c into dt. C value is 1, dt is 2. C into that is 1 into 2, that is equal to 2 units. So taking point 2 as a center point, draw one circle with a radius equal to 2 units. Now the projectile moves to position 1. Position 1, the time required for the projectile to reach point B is 1 second. So distance traveled by the projectile is v into dt, that is 1 into 1, that is equal to 1 unit. Now the distance traveled by the projectile is c into dt. C value is 1, dt is 1. So 1 into 1. That is 1 unit. Taking 1 as a center point, draw one more circle with a radius equal to 1 radius, with a radius equal to 1 unit. So this is a case for m equal to 1 or sonic flow. Okay, now last case, when m is greater than 1, this is a supersonic flow. When m is greater than 1, the flow is known as supersonic flow. Let v equal to 1 unit and c equal to 0.5 unit. So you have to choose the values of v and c in such a way that you have to get a Mach number greater than 1. So it is possible when v equal to 1 and c equal to 0.5. So that m equal to v by c, that is equal to 1 divided by 0.5, that becomes 2.0, which is greater than unity. So let me discuss the drawing procedure. So here again draw one straight line, that is AB. So at A again mark point 4. Okay, now the projectile moves from left to right. It reaches point B in 4 seconds. So value of V is 1, C is 0.5. So the distance traveled by the projectile is given by V into dt, that is 1 into 4, that is 4 units. 4 units. Next, the distance traveled by the disturbance or pressure waves is given by C into dt, that is C value is 0.5, dt is 4. 0.5 into 2, that 0.5 into 4, that becomes 2. Taking A as the center point, draw on a circle with a radius equal to 2 units. Now the projectile moves to point 3. So the time taken for the projectile to move from 3 to B is 3 seconds now. 3 seconds is remaining. So distance traveled by the projectile is given by V into dt. So V value is 1, dt is 3. That is 3 units. The distance traveled by the disturbance or pressure waves is given by C into dt. dt value is 3 and C value is 0.5. 3 into 0.5, that becomes 1.5. So taking 3 as a center point, draw one circle with a radius equal to 1.5 units. Now the projectile moves to point 2. At point 2, for the projectile to reach to point B, it requires 2 seconds. So distance traveled by the projectile is given by V into dt. So V value is 1, dt value is 2 seconds. 2 into 1, that is 2 units. Now the distance traveled by the pressure wave is given by C into dt. C value is 0.5, dt is 2. 0.5 into 2, that is 1. Taking 2 as a center point, draw one circle with a radius equal to 1 unit. Now the projectile moves from 2 to 1. So time required for the projectile to move the position B is 1 second. So distance traveled by the projectile is given by V into dt. V value is 1, 1 into 1, time interval is 1. So that is equal to 1 unit. Now distance traveled by the pressure wave is or sound wave is given by C into dt. C value is 0.5 and dt value is 1. So 0.5 unit. Taking 1 as a center point, draw one circle with a radius equal to 0.5. So that is related to Mach number greater than 1. Now I had to define one more thing is there. If we draw a tangent to the different circles which represent the propagated spherical waves or pressure waves on both the sides, we shall get a cone with a vertex at B. This cone is Mach cone, is known as Mach cone. So we have like 1, 2, 3, 4 circles. When you are going to draw one tangent to these circles in the outer side, we are going to get one cone. That cone is known as such that the point of beginning of the tangent should be at point B. So that cone, whatever we are going to get, it is called as Mach cone. Now let us define what is Mach angle. This is defined as half of the angle of the Mach cone. So in figure C, angle alpha is known as Mach angle. You can see here in figure the half of the angle, that is D1B or 1BD is called as alpha. There is a half of the cone angle, that is alpha. So in triangle 1BD of figure C, the distance 1B, that is distance 1B, along the straight line the projectile is going to move. So that is equal to 1B equal to V. The distance 1D, the velocity of the sound wave. So sound waves are going to move in all directions. The 1D is C. Okay, that is equal to C. So velocity of the sound wave equal to C. Hence we have applying sine rule or sine here. Sine alpha equal to opposite by hypotenuse. Opposite is 1D. 1D divided by hypotenuse here is 1B. So 1D divided by 1B. 1D is taken as C, that is the velocity of sound wave, divided by 1B, that is velocity of projectile, that is C by V. We hope you remember M equal to V by C, that is a Mach number. Now you can take C to the denominator. That time it becomes 1 divided by V by C. V by C is 1 M. So that is equal to sine alpha equal to 1 by M or 1 by Mach number. Very important correlation for solving the problem. Now zone of action. What is zone of action? When M is greater than 1, the effect of the disturbance is felt only in the region inside the Mach cone. So when M, that's a supersonic region. So you can see from the diagram, effect of propagation of the sound wave can be felt inside that cone itself. This region is called as zone of action. When a zone of silence, when M is greater than 1, there is no effect of disturbance in the region outside the Mach cone. You can see the Mach cone, there is no disturbance propagating outside the Mach cone. So this region which is outside the Mach cone is called zone of silence. You can see there.